You know, when you look at one of those global warming maps, it's not just this uniform blanket of red, right? It almost looks like someone took a paintbrush and just lit the very, very top of the world on fire. So today, we're going to dive into this really fascinating and honestly super important climate puzzle.
And yeah, I kind of mean that literally. There's this bizarre sped-up warming happening right at the North Pole. It's got scientists really worried, and as you're about to see, it has consequences for every single one of us.
Get this. In some parts of the Arctic, the warming isn't just a little bit faster. Nope, it's happening 4 times faster than the rest of the planet. 4. So what in the world is going on up there?
To really get our heads around this, first we've got to understand the sheer scale of this warming. This isn't just some minor little blip in the data. It's a massive, supercharged effect.
And when you see the numbers side by side, wow, the contrast is just staggering. Globally, we've warmed about 1.1 degrees Celsius, but the Arctic, it's shot up by 3, maybe even 4 degrees in that same time. It's not even in the same league.
And this whole thing has a name. It's called Arctic amplification. That's the key idea for everything we're talking about today. It's not that the whole world is warming evenly. It's that the Arctic is on a total runaway train. So the big question is, why?
Well, the answer lies in a really simple, almost elegant piece of physics. I like to call it the white t-shirt effect. And it's basically the main engine driving this entire situation.
On the most basic level, it all comes down to color. Bright white sea ice is like a gigantic mirror. It reflects most of the sun's energy straight back out into space. But that dark, deep blue ocean, it does the exact opposite. It just soaks that energy right up like a sponge.
Now, the official sciencey term for this is albedo. It actually comes from the Latin word for whiteness. So, something with a high albedo is super reflective, like fresh snow. Something with a low albedo is super absorbent, like black asphalt. Or, you guessed it, a dark ocean.
And this is just the perfect way to think about it. For thousands of years, the Arctic basically wore a protective white t-shirt. It reflected the summer sun, stayed cool. But as that ice melts away, it's being forced to change into a black t-shirt, which, as we all know, gets crazy hot on a sunny day.
Okay, but here's where it gets really serious. This wardrobe change, it isn't a one-time thing. It kicks off this dangerous, self-perpetuating cycle, what scientists call a vicious feedback loop.
Right, it kind of seems weird at first. How can losing just a little bit of ice cause such a huge, amplified warming effect? Well, the answer is that the melting starts to feed on itself.
Okay, so let's walk through this cycle. Step 1, the atmosphere warms up, just a little. Step 2, this melts some of that reflective white ice, which exposes the dark ocean underneath. Step 3, that dark water then absorbs way more heat from the sun. Step 4, now you have warmer water, which melts even more ice from below and around the edges. Step 5, and now you have even more dark water exposed. The whole cycle just repeats, getting faster and more intense every single summer.
So that's the real transformation here. The Arctic is fundamentally changing its job description. For ages, it was the planet's mirror, protecting us from too much heat. And now it's turning into a giant sponge, just soaking it all up.
And as if that wasn't enough, the albedo effect isn't the only thing going on. As the ice gets thinner, it's not as good at insulating the cold air from the warmer ocean water below. On top of that, you've got ocean currents literally pumping warmer water up from the Atlantic and the Pacific. So the ice is really getting attacked from all sides.
So at this point, you might be thinking, okay, that sounds bad for polar bears, but I live in Miami, why should I care? Well, it turns out that what happens in the Arctic doesn't stay in the Arctic. It's the hidden regulator of your weather. You see, there's this high-speed river of air that circles the northern hemisphere. It's called the jet stream. And what keeps it strong and stable is one simple thing: the huge temperature difference between the freezing cold Arctic and the hot tropics. So when that temperature difference is really big, the jet stream is strong and flows in a pretty straight line. It's like a tight fence that keeps all that frigid polar air locked up in the north. But as the Arctic warms up so fast, that temperature difference shrinks, and the jet stream, it slows down, it gets weak, and it gets wobbly. And a wobbly jet stream is bad news for all of us. It allows these huge chunks of freezing polar air to just dip way down south, causing things like that crazy freeze in Texas. And at the same time, it allows giant ridges of hot tropical air to push much farther north, which fuels those record-shattering heat waves in places like Europe. The fence is basically broken.
You know, when you put it all together, this is really the best way to think about it. The Arctic, with its huge shield of bright white ice, has always been the planet's air conditioner. It reflects away heat and keeps our whole global climate engine running smoothly.
And as we keep dismantling that system, as we swap out that giant mirror for a giant sponge, we are effectively breaking our own air conditioner. So, the final, really critical question we're all left with is this: what happens to all of us when it finally breaks for good?